Quadratics is a topic you'll visit time and time again throughout A-level. Because of this, it is vital that we both understand them and have the knowledge to manipulate them. We're all used to the standard quadratic form, but sometimes functions that at first don't appear quadratic may exhibit quadratic behaviour. Examples of these are trigonometric and exponential functions, and these are all topics we'll come across further down the line. So let's start with the basics. We will split all quadratics into either a positive or negative. The coefficient of x squared is what defines this property. If it is a positive number, it is a positive quadratic, and if it is a negative number, it is a negative quadratic. What do we mean by positive and negative quadratics? Well, put simply, a positive quadratic is a sort of U or V shape, and a negative is the reverse of this, more like an N or a hill. These can take many different shapes and sizes. Some just appear at different areas in our grid, i.e. they have been translated. Others may appear much slimmer or fatter, something referred to as stretched. This is true for both positive and negative quadratics. Let's bullet point the four main methods we're going to use to understand the characteristics of a quadratic. The first two, factorizing and the quadratic formula, are used to determine the roots of a quadratic. The third method, completing the square, helps us establish the vertex. And the fourth thing we're going to have a look at is solving quadratic inequalities themselves. Factorizing is just putting it into double brackets. The advantage of this is we can read off the roots. The roots are just where the quadratic graph crosses the x-axis, and knowing these points allows us to sketch a fairly accurate graph. Sometimes when factorizing we get a double bracket that is the same. We refer to this as a repeated root. This tells us that the graph itself just touches the x-axis instead of passing through. The quadratic formula is something we should be familiar with from GCSE. It is just a method we can use if we are struggling to factorise. The solutions we get at the end are our roots, the same we would have got if we managed to factorise it in the first place. This is something you don't have to do in the exam, although some students quite like it. Now, before we get on to completing the square, let's recall what we mean by a vertex. A vertex is just the tip of a quadratic graph, i.e. the minimum or maximum point depending on whether it is a positive or negative graph. Completing the square is the method we use to determine this vertex. Our first step is to halve the x coefficient, i.e. the number multiplying the x. This gives us the basis of our bracket squared. After this step we must square the number in the bracket and then subtract it. And once tidied up and in this form we can simply read off the vertex by taking the negative of the number in the bracket as our x coordinate and the number at the end as our y coordinate. Sometimes we are asked to complete the square of an equation where the number in front of the x squared isn't 1. The problem with this is our method only works on equations with 1x squared. To get around this, we first factorise out to create a bracket with a single x squared. Then we proceed to complete the square of the bit in the bracket using normal methods. Don't forget at the end to multiply back out. This also works in the case where we have a negative x squared. Simply bring minus 1 out as a factor and just proceed like before. It's important to note the number outside the bracket at the very end has no effect on the vertex itself. To solve quadratic inequalities, we must first produce an accurate sketch of the graph. This involves determining its roots and whether it is a positive or negative graph. And once we have a sketch, we can easily see the solutions. For this example, with greater than or equal to 0, we're interested in the parts that are above the x-axis. There are many different techniques to then writing down the final inequalities. On this second example, with less than 0, we're interested in the parts of the graph that are below the x-axis. Some students, after some practice, can just see the solutions on the graph, whilst others may use methods such as the number line method we've seen in this example. It's important to remember that if the original equation has an equal to in the inequality, you should include it in your answer, and vice versa. If there's no equal to in a question, you shouldn't include it in your answer.